right now. We look at this piece, 2x minus 3 to the 4th power. Whoa. What's the inside? What's the outside? Okay. Derivative 2x minus 3. Derivative of the outside. Multiply them together. So watch how we can think about it quickly. Derivative of the inside. Derivative of the outside. With the inside left alone. Look at how quick that happens. See that? I didn't draw the boxes. I'll do it once more. 3x minus 2 raised to the 5th power. Derivative of the inside, 3. Derivative of the outside, so I'll create a 15, right? Times the inside left alone. Derivative of the inside times derivative of the outside with the inside left alone. So you can kind of watch as we're doing that. What's the inside? What's the outside? 6u to the 5th. Yep, constants just come along for the ride. Pick up that 6. It's got to be included. Derivative of 6u to the 5th. 30u to the 4th. Derivative of x minus x squared. Now, I can distribute the 30 both to the 1 and the 2, can I? So it becomes 30 minus 60x times x minus x squared to the 4th power. Thirty times 1, 30 times 2. Yes, that's fine. Yep. Okay, negative 4 is secant of 5x squared. What's the inside? 5x squared. What's the outside? Derivative of 5x squared is 10x. Uh-oh, does anybody remember what the derivative of negative 4 secant of u is? Very good. Negative 4 secant of u, tangent of u. So you can see that part of the practice in the chain rules to start to remember what the derivatives of the trigonometric functions are. I multiply these together, I get a negative 40x. I get secant of what? 5x squared, tangent of. Now, if you can't appreciate how amazing it is that we can do it that quickly, then you're missing something. But you guys, we're finding derivatives really, really fast, okay? Really, really fast. You remember the problem on the test, on the final exam? You wanted to find an equation for a line tangent, didn't you? Yeah, well, you had to find a derivative, right? Raise your hand if you multiplied it out 10 times. Exactly. Good for you for trying it, and you got it right, didn't you? But how could we do it instead? What's the inside? What's the outside? So 10u to the 9th and negative 1, so negative 10 times 1 minus x to the 9th. Zane, wouldn't that have been nice to know that, huh? Yeah. Look at how quick that is. So the chain rule is truly an impressive, impressive tool. Question? Well, I know that some people have already looked ahead at the chain rule and investigated it, but he didn't feel it would be right to use it on a test, which means Chris has a star quality of honesty. He says, I don't want to do this because I know we haven't learned it yet, but I would have totally given him credit if he did. So he doesn't exactly need the extra credit points. So, all right, this next one I'm going to rewrite is negative 5 times x plus 5 to what power? Negative 7. Notice that you could use the quotient rule, but I think that the chain rule is a better option in this situation. And so therefore, I have the inside, which is x plus 5. What's the outside? Negative 5u to negative 7. Derivative of x plus 5 is 1. Derivative of negative 5u to negative 7. Yep, 35 over u to the 8th. Now, here's one thing that's kind of nice. Look at this. If the derivative of the inside is 1, then it doesn't really impact the outside at all, does it? So it is just 35 over x plus 5 to the 8th power. Are you all satisfied that you know the basics of the chain rule? Then let's try to get more complicated, okay? And it begins here, okay? It begins here. We have 2x times 4 minus x to the 4th power. This is more than one rule. Do you know the two rules that are involved in taking this derivative? The product and the chain rule, okay? So Chris sees that right here we have what you would refer to as the chain rule. But then you have 2x, not just a 2, but a 2x times. So we have the product rule. This is where I start to lose people, and I thought that last year was the best we had done, so I'm going to try to take the same approach. You're wondering how to set it up. Do we start by setting up the chain rule, or would you start by setting up the product rule? This is how you determine. You consider your order of operations. Suppose I were to plug something in for x, like 1, okay? You would take 4 minus 1 and raise it to the 4th, right? You would take 2 times 1 and get 2. And at the very end, you would multiply those two together, correct? So because the last thing you did was multiply those two expressions together, that's the first thing that you need to set up. So we set up the product rule. So follow your order of operations. You see that? Okay. So no big deal. We'll call this F and we'll call this G. So we have F prime G plus G prime F. What is the derivative of F? 2 times 4 minus x raised to the 4th power. Hey, no big deal, right? I mean, that was super easy. Nobody's complaining about that. Plus 2x times, now I need to do the derivative of 4 minus x to the 4th. How do I do that? Chain rule. So I'm going to take a little bit of work off to the side over here. Just draw my boxes. You don't have to on the test, but it does give me an indication of what the heck you're doing. I got a 4 minus x over here. What do I have here? U to the 4th, 4u cubed, negative 1. So what do I get? Yeah. Okay. Here is a rule that you need to perform on the test. Anytime you do the product rule in cooperation with the chain rule or the quotient rule in cooperation with the chain rule, you must write it in factored form afterwards. Why? Because that's the way I see the answers expressed consistently, both within your book and on the AP exam. So we're going to follow through with that. Here I have 2 times 4 minus x to the 4th. And this is going to become a negative 8x times 4 minus x to the 3rd. Let's take out a common factor. What's the common factor? 2 times 4 minus x. Raised to what power? To the 3rd power. Is everybody okay with that? If you take out a 2 times 4 minus x to the 3rd, what remains? 4 minus x minus 4x, right? D. Weiland. So I took the 2 times 4 minus x to the 3rd power. I took it out of this. So I just have a 4 minus x. And I took this out of this. That 4 minus x to the 3rd is gone, but from the 8x, I have 4x left over. Can you combine any terms here? What terms can you combine? Negative x and negative 4x make. So this is 4 minus 5x, isn't it? So my final answer is 2 times 4 minus x cubed times 4 minus 5x. If you wanted to, could you distribute the 2 to the 4 minus x? No, because it's being cubed. Could you distribute the 2 to the 4 minus 5x? Yes, I would allow for either one of those answers. We clear? Okay, then I will state this. When this problem occurs on the test, many people do it incorrectly and do not get it right. And on the final exam, people do not get it right. When you get this problem in your assignment, you need to make sure that you're taking a close look at it, folks. Let's look at another one. Sine squared of 3x. Uh-oh. This one's tough. Remember that this is sine of 3x quantity squared. That's what that means, right? So if you look at this, we would first take 3 and multiply it by x. What's the next operation? Take the sine of it. What's the next operation? Square it. So therefore, the outermost structure is u squared with the chain rule. What's the inside? Sine of 3x. These mean the same thing. Yep. That'll be last year trig. These mean the same thing. Got to convince yourself of it. That's right. That's why they write the squared on the sine. So that means after you've taken 3 times x and after you've taken the sine of it, then you square it. That's what it's saying. Okay. All right. What's derivative of u squared? 2u. And derivative sine of 3x. I have to use the chain rule, don't I? No. Because right here. Remember when I wrote this on the board originally, we said you would have to use a chain rule for that, right? Here it is again. No big deal. You're going to set up the chain rule like 3-4 times in some problems. This is just twice. So what's the inside of this? What's the outside? What's the derivative of 3x? What's the derivative sine of u? So that means that this derivative is 3 cosine of 3x. What do I put in place of the u? Sine of 3x. So I have 2 times sine of 3x times 3 cosine of 3x. What terms am I allowed to multiply together? 2 and the 3 to make 6 sine of 3x cosine of 3x. Isn't that beautiful? Flip it over. That was it for that. You already know how to do those 4. They're super easy for you. Let's try something that's a little bit more challenging. Negative 3x squared, cosine of 4x. This involves more than one rule. Can you tell me what rule it involves? Product and the chain. Very good. Do I start by setting up the product rule or do I start by setting up the chain rule? Product rule. Very good. Good job. So this is F and this is G. So F prime would be negative 6x times cosine of 4x. Hey, awesome. We're off to a good start. Plus negative 3x squared times, now I need the derivative of cosine of 4x. What do I need to use for that? The chain rule. What's the inside? Outside? So I get negative sine of u and 4. So that's negative 4 sine of 4x. Negative times a negative. So I have negative 6x cosine of 4x plus 12x squared sine of 4x. And I told you that anytime you use the chain rule in cooperation with the product rule like that, you must take out the common factor. What is the common factor? Yep, I would take out a negative 6x. What are you left with? Cosine of 4x. 2x sine of 4x. What do you think? Not too bad, huh? Yeah. Yeah, so without a doubt. So Dylan's question is this. Suppose I have 2x times the sine of 8x, and I want to take that derivative. Without a doubt, when I do the work, derivative 2x is 2 times sine of 8x, right? Plus 2x times, now I'm going to take the derivative sine of 8x. I don't ever write the box or take my time. I just do it. What's the derivative of 8x? 8, derivative sine, cosine with the inside left alone. Boom. So it saves me time, but that comes with practice, and you guys will get better at that over time. When in doubt, draw the boxes. If you don't have to, write it out like that. How about we do letter C? I know, we're going to need to create some extra space for B. So what's the outer structure for letter C? C division, so you're going to set up the quotient rule. Okay. Well, that's going to be F prime G minus G prime F over G squared. So we might have to invade the space of D for this problem. I maybe didn't leave enough space. We'll see, but looks like there's a lot of stuff involved there, doesn't it? Okay. But fortunately, we're really good at math. And so, we're going to be okay. Okay. Start with F prime. What rule do I have to use for that? I got to use a chain rule. So, yeah, so I am going to invade this, and I'm going to, put it on a separate sheet of paper because I want to make sure I got space to show my work here. So the inside is 3x minus 5, and the outside is what? So I got 4u cubed, and I got 3. So what's the derivative? Both times 3x minus 5 to the... Okay, cool. All right, so we just did the f prime, right? All right, so we got that one part done. Good job. 12 times 3x minus 5 raised to the third power. Oh, I could just write g down, can't I? Well, that's nice. 2 minus x raised to the 6th power. Sweet. Minus, now I got g prime. Chain rule again? Okay. 2 minus x, u to the 6th. What, negative 1? 6u to the 5th? So negative 6 times 2 minus x to the 5th power? So that's going to change the minus to a plus, isn't it? So plus 6 times 2 minus x raised to the 5th power. Then what? 3x minus 5 raised to the fourth power. All over, holy shnikes. Yeah. At this, no, Grant. Oh, if it wasn't anti-bullying day, I'd hit you. Okay. All right. There's something that like excitement needs to fill you inside right now. You should be saying, oh, this is awesome because, yeah, exactly. Check this out. Look, you got 2 minus x to the 12th. Do you have a factor of 2 minus x in the top? Yeah, all of them have at least 5, right? So let's get rid of 5 of them. So that's completely gone. This goes down to 1, and this goes down to 7. So then we have 12 times 3x minus 5 to the third times 2 minus x plus 6 times 3x minus 5 to the fourth. All over. So that was kind of nice, huh? Hey, does the top have a common factor? What is it? Yeah, 6 times 3x minus 5 to the third. Take that out. What are you left with here? 2 times 2 minus x, which would be 4 minus 2x. 4 minus 2x. And if I take the 6 times 3x minus 5 to the third out of that, I'm left with plus 3x minus 5. Yep. All over 2 minus x to the seventh. So what terms can you combine there? I get a positive x and a minus 1, right? So the final answer is 6 times 3x minus 5 cubed times x minus 1 all over 2 minus x to the seventh. Is that not awesome? All right. I never know what's going to come out of the mouth. Thank you for sharing. Yes. This one? Thank you. Do you see that 6 times 3x minus 5 to the third is the common factor? Okay. As I take a 6 times 3x minus 5 from here, I'm left with 2 from the 12, and I'm left with the 2 minus x. 2 times 2 is 4. 2 times negative x is 2x. We all good now? Okay. Anybody else? Excellent question. Thank you for asking, Riley, because I guarantee somebody else was thinking the same thing. Excellent. Okay. Somewhere we need to create room. Either a scratch sheet of paper. That was pretty large. This next one is not going to be that large. Okay. But we are going to do D. Example B. No, yeah, you could totally go up there if you want. We're going to do D right now. We're going to get back to B. B is going to take a while. We might have to invade tomorrow's time a little bit and give you some more work time on Friday instead. I think I built in enough time when I said test on Friday for that, so next Friday. Okay, this is the big thing is is, can you identify how we set this up? Why the product rule? Because you multiply by -8, right? But -8 is a constant. So that does not matter to us. So pretend the -8 wasn't even there. We'll bring it back in a second, but pretend the -8 wasn't even there. What's the last thing you do now? Raise it to the 4th power. So therefore, u to the 4th. What's the inside? 4x, not 4x minus 2, but sine of 4x minus 2. Now, see how I got rid of that -8? We got to put that -8 back here. It can't just be gone forever. I just got rid of it so we could understand the problem better. You'll see in a second. If the question isn't answered for you in a second, let's go back to it, okay? So if you were to rewrite this, it would be -8 times sine of 4x minus 2 all to the 4th power. So again, but the -8 is just a constant, just comes along for fun. It's just part of, hey, we got a party going on here, okay? All right? So -32. Chain rule, good. We got 4x minus 2, right? And we got sine of u. Sine of u? Cosine of u. Derivative of 4x minus 2? 4. So that'll be 4 cosine of 4x minus 2. So now we got to multiply these together. 4 times -32. 128. We have u to the 3rd, so that's sine cubed of 4x minus 2. What have I not written yet? The cosine of 4x minus 2. That's the derivative. That's enough for today. Tomorrow, what we want to be able to do is we want to be able to do problem B, and then we also want to be able to do these problems. So you're going to get all day Friday to work on your assignment, and anytime you have tomorrow. That's the answer. Question. They should all be. I believe that they all are.